we studied the integrals of some standard functions and methods of integrations, etc. earlier. Now, we are going to learn about the applications of integrals. Before that, let us we know some integration. What is a integration? So, already you studied that integration is anti-differentiation of the function, and the integral of a function y is equal to f of x, the integration of any function y is equal to f of x is defined on the domain of f, then that integration is called indefinite integration. Suppose the integration of f of y is equal to f of x is defined on an interval a to b, which is subset of the domain of f, is called definite integration. Already you studied this indefinite integration and definite integration earlier. Now, what is the definite integration? It is defined on the interval a to b, which is subset of the domain of f. And the definite integration of the function y is equal to f of x is defined as integral a to b f of x dx is equal to f of b minus f of a, where f of x is the integration of the function f of x with dx. Now, find the indefinite integration of the function and substitute the upper limit and lower limit, and difference of the upper limit to lower limit gives the definite integration of the function. And already you studied the methods also, how to find the integration in different methods. That is already over. Now, we are going to learn about applications of these integrations. The major application of the integrations is finding areas of the region bounded by the curves. Now, let us take some function y is equal to f of x. Now, suppose the function is, the graph of the function is like this, and what is the area of the region bounded by this curve y is equal to f of x with x-axis, and between the lines x is equal to a and x is equal to b. Now, this is the area bounded by this curve between x-axis and the lines x is equal to a and x is equal to b. Similarly, suppose if another function x is equal to f of y given like this, suppose the graph is like this. Now, the area of the region bounded by this curve x is equal to f of y with y-axis and bounded by the lines y is equal to c and y is equal to d. Now, this area, now it can be determined by using the integrations. Now, this area of the region y is equal to area of the region bounded by y is equal to f of x with respect to x-axis, or area of the region bounded by the curve x is equal to f of y with respect to y-axis, or partly some of the portion is above the x-axis and some of the portion below the x-axis, then finding the areas of the curves, areas of the regions formed by the curves, etc., etc. All these areas can be determined by the definite integration. So that the major application of the integrations is finding the areas. Now let us find how to find the areas of these curves. Now let us find the area of the region bounded by some curve y is equal to f of x. X-axis, and between the lines x is equal to a and x is equal to b. Now let us take the function or the curve y is equal to f of x like this as shown in figure, just above the x-axis like this. Let it be the function or a curve y is equal to f of x and x is equal to a parallel to the y-axis, and x is equal to b, it is another line parallel to the y-axis. Now we are going to find the area of the region bounded by this curve y is equal to f of x with x-axis and the lines x is equal to a and x is equal to b. So this part. Now to determine the area, we just consider a strip. It is a strip whose length or height is y and width is dx. Here dx means that it is a small negligible quantity in x. So now these two vertical lines are very much close, and y is the length of the strip. And now here the area of the strip, area of the strip is equal to area of the strip is given by y into dx. You know, here these two strips are very much close, so that almost these two lengths are same, and since it is dx, therefore the area bounded by these lines is almost nearer to y into d of x, y into dx. Therefore this is the area of the strip known as elementary area. Elementary area. And this strip is known as arbitrary strip, and this area of the strip is denoted by dA. Now if we consider a large number of strips in between x is equal to a and x is equal to b and find their areas, find the elementary areas that are formed between these two lines and add them. Now the sum of those elementary areas gives rise to area of the region bounded by the curve y is equal to f of x with x-axis and x is equal to a, x is equal to b. And therefore the area of the region bounded by the curve y is equal to f of x with x-axis and x is equal to a, x is equal to b is given by integral of dA under the limits a to b. So it is integral of dA under the limits a to b represents the area of the region, as well as it is the sum of the large number of strips that are defined between x is equal to a and x is equal to b. It is the sum of infinity, sum to infinity, that is integral a to b into integral a to b d of a, which is equals to integral a to b, but you know d of a is equal to y dx, that is equal to integral a to b, where y is equal to f of x into dx. So you just integrate the given curve f of x with respect to dx under the limits a to b. That gives the area of the region bounded by the curve with x-axis between the lines x is equal to a and x is equal to b. Suppose if we consider one more curve, x is equal to f of y. Let us take one curve, x is equal to f of y, and the area of the region bounded by the curve x is equal to f of y with y-axis between the lines y is equal to c and y is equal to d. Now in this case, the graph be like this. Now this is x-axis, it is y-axis and origin, and this is the curve x is equal to f of y. Now this is y is equal to c line which is parallel to x-axis, and this is y is equal to d line parallel to the y is equal to c line parallel to x-axis, and y is equal to d, it is also parallel to the x-axis. Now let us find the area of this curve with y-axis between the lines y is equal to c and y is equal to d. Now here also we can consider a small strip, an arbitrary strip whose length is x units and width is dy. Then the area of this elementary strip or elementary area dA is equal to x into dy. Now the large number of these elementary areas gives rise to area of the region bounded by this curve with y-axis. Therefore, finally the area is given by integral x dy under the limits c to d, that is equal to integral c to d x dy, where x is equal to f of y dy. Therefore, the area of the region bounded by the curve with respect to y-axis is integral c to d x dy or integral c to d fy dy, and the area of the region bounded by the curve with a x-axis between the limits x is equal to a and x is equal to b is given by integral a to b f of x dx.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.